Hello! In this video, I want to talk to you about some very general ideas relating to differences in the effects of blunt spinal cord injury versus sharp spinal cord injury. Now, as I've said previously, blunt spinal cord injury is far more common than sharp spinal cord injury. However, by studying the difference between these two, it does highlight to us how spinal cord injuries in general affect the neurons and axons running within this part of the central nervous system. So the first thing I'm going to do is I'm just going to draw a cartoonish depiction of the spinal cord just as a cylinder. Okay, so here we've got, we're going to draw a cylinder here, and this is our spinal cord. And I'm going to represent just two adjacent segments of the spinal cord, and I'm going to put a line just across there. So these could be, for example, the C5 spinal cord segment, and this could be the C6 spinal cord segment. Now, as you should know, each spinal cord segment is connected to the peripheral nervous system via the dorsal and ventral roots. And these are in fact formed from the merging of multiple rootlets. So we've got lots and lots of, we'll say in this case, dorsal rootlets here, which come together along with the ventral rootlets to form our spinal nerve. And remember that there is a dorsal root ganglion and then our spinal nerve just there. And we'll show the same thing for this C6 segment just here. So we've got lots of dorsal rootlets coming together to form a dorsal root, lots of ventral rootlets coming together to form a ventral root, and then there's a DRG and a spinal nerve. Of course, this is replicated on the other side as well, but I'm only showing you the one half of the cord for clarity. Furthermore, what we also need to add is, of course, the central core of grey matter running down through the spinal cord. And I'll just draw this as just a smaller grey cylinder running down through the centre like this. So we're now in a position to think in a little bit more detail about what these injuries are actually doing. And we need to think about a couple of important things. The first thing that we need to consider is some numbers, all right? In fact, you would think it should be well known how many neurons are in the spinal cord and how many axons are in the spinal cord. And indeed, that is the case for non-human animals. But in humans, we actually don't have particularly accurate or replicatable numbers for this. However, I'm going to give you some numbers just to give us the idea of the order of magnitude here. It seems to be the case that for any individual spinal cord segment, there are around 5 million neuronal cell bodies. Okay, so it seems that within any individual spinal cord segment, there are around 5 million neurons. So there are around 5 million neurons within any individual spinal cord segment. So that means that in the figure I've shown you here, there's a total of 10 million neurons. And remember, you know, these neurons are found within this central core of grey matter, within the dorsal and the ventral horns. And these are the neurons which are either lower motor neuron cell bodies or the cell bodies, say, of second order sensory neurons. So each spinal cord segment has around 5 million neurons within its grey matter. And then remember that within the cord, we have a whole load of ascending and descending axons running through the white matter. So we've got a load of descending axons going down. So these would be axons of the motor system. And then we've got a load of ascending axons travelling up. And these are axons of the sensory system. All right. And of course, the axons of the motor and sensory system communicate with the grey matter of the spinal cord. So, for example, if these were axons of the corticospinal tract, some of them would be going into the ventral horn to synapse on lower motor neurons. And we know that within the white matter of the spinal cord, across its cross-sectional area, there are something like 5 million axons. And once again, this is a highly, an estimate, okay? But it's believed that across the cross-sectional area of the spinal cord, so right across the cord, there's something of the order of 5 million axons. Now, it's going to become apparent to you why I've given you these numbers shortly, because it's going to illustrate something important about spinal cord injury. So let's start off by introducing an injury to this spinal cord. And this injury that we're going to induce, I'm going to use a yellow colour for it, is going to be a sharp transection. And this is a sharp transection which is going to be complete. It's going to sit between the C5 and C6 cord segments. So the line that it's going to take is this. Okay, so here is our sharp transection. Okay, now let's have a think about the consequences of this sharp transection. What structures has it passed through? What structures has it destroyed? Well, because this is a complete spinal cord injury, a complete sharp transection of the spinal cord, what we must appreciate is that it has transected all of the axons of the spinal cord, okay? So even though this lesion looks relatively small, it is devastating because it has transected all of those 5 million axons running up and down through the cord. And what that means is that below the level of the lesion here, we are going to see paralysis, motor paralysis, we are going to see sensory loss, and we are going to see autonomic dysfunction. So this has transected the 5 million axons and has led to very, very severe problems below the level of the lesion. Has this sharp transection had any impact upon the grey matter? Have any of the neurons within the grey matter been killed as a consequence of this sharp transection? And the answer to that is, of course, yes. However, if you look carefully, only a small subset of these neurons running through this core of grey matter will have been destroyed. If you think about it, within this cylinder of grey matter, which includes dorsal and ventral horns, probably less than 0.5% of the axons have been destroyed, okay? And that is a tiny number when we consider that there is 10 million in total. So a sharp transection will actually have a minimal effect upon the neurons themselves that live within the spinal cord. And that means that if we consider the effects below the lesion, they're going to be entirely, for example, upper motor neuron effects. There is not really going to be any lower motor neuron effects of this sharp transection because most of the lower motor neurons have been spared. Now, let's do a different lesion. Let's now do a blunt transection which has destroyed the entirety of one of these spinal cord segments. So now let's do a blunt transection. I'll use blue, and in this case this blunt transection has destroyed all of this area here. Okay, it has destroyed the entirety of the C5 spinal cord segment. Now let's once again, like we did for the sharp transection, think about the effects. Because the entirety of this C5 spinal cord segment has been destroyed, that means that we have transected all of the 5 million axons running down through that segment. So it's identical to the sharp transection with respect to the axons because they have all been transected, they have all been destroyed, meaning that below the level of this lesion we are going to see sensory loss and we're going to see paralysis of the upper motor neuron type because we have destroyed the axons of upper motor neurons. So that's relatively straightforward to understand. Now let's have a think about the effect on the grey matter. Well, note that in this lesion here that we've drawn on, we destroyed the entirety of the grey matter within the C5 spinal cord segment. So let me repeat that. We destroyed all of the grey matter within the C5 spinal cord segment. So that means for both left and right hand sides, even though we didn't draw on the right hand sides, we have destroyed all of the lower motor neurons and all of the second order sensory neurons. So let's deal with these individually. We've destroyed all of the lower motor neurons, all of the motor neurons in the ventral horns of the spinal cord. And the consequence of that is that for the C5 level only, we're going to see lower motor neuron signs because we have destroyed the lower motor neurons, which would normally be sending their axons through the ventral roots out through the spinal nerves. So the C5 myotome is going to experience a lower motor neuron defect, okay? Whilst the C6 levels and below are going to experience an upper motor neuron defect because we transected the axons of upper motor neurons but did not damage any lower motor neuron cell bodies at these levels. So we have destroyed the C5, the motor neurons, the lower motor neurons that supply the C5 myotome. What about the sensory system? Well, in the sensory system, what we have is we have destroyed two components. The first component we've already discussed, and that is the axons of the dorsal columns and spinothalamic tracts, which were ascending through the destroyed segments. In destroying the axons of the long sensory pathways, that means that we render the levels below anesthetic. Okay, so the levels below are not able to send any sensory information up beyond the level of the lesion because their axons have been transected. Furthermore, because we have destroyed the second order sensory neurons within the C5 cord segment, the C5 cord segment will also be completely anesthetic. And this is because not only have we transected the axons of the long tracts, but we have also destroyed the cell bodies of second order sensory neurons. So this is just a fairly important concept really I'm trying to communicate to you. All too often people think that spinal cord injury is just about the long tracts. However, you must remember that particularly in real life scenarios where much of the cord is involved in a lesion, we are also damaging the cell bodies of spinal cord neurons. And this will also have an effect on the motor and sensory systems. So just remember, spinal cord injuries involve not just long tracts, but also neurons within the grey matter of the affected segments. So thank you for listening.